value that we passed in the URL. Can also be passed as a post parameter, of course. But the cross-site scripting attack string is there as well. It's actually pretty easy to see how this works in .NET code. Again, for people that work with .NET frequently, Dotnet Reflector is another tool that I highly recommend. .NET's not open source per se, but it's not licensed as open source, but the vast majority of .NET controls can be easily decompiled, and Microsoft makes no attempt to prevent that. So you can, it's nice because you can go in and actually look to see how the inner workings of .NET work, with the exception of a handful of classes. So the form control is what we were attacking. Now you didn't, when we go back to the view state, you didn't actually see anything saying form control on there. When the view state is constructed, it doesn't assign names to the data in here. So the inner HTML is an attribute of some control, and it happens to be the form control. The reason the server knows it's for their form control is because it's the first on the list, and the server knows, okay, well, the first element in my list of attributes is the form control, and if we had more forms, there would be more slots in that list, and you know, as you start to look at more complicated view states, you can see how it gets pieced out. But one of the nice things about this from an attacker point of view is that you don't have to know really how the code is structured on the server side. You don't have to know what the name of that control is in the source code. You can deduce most of what you need, in many cases, all of what you need, just from the structure of the view state. So and also the structure of the HTML. We know there's a form control on the page just by looking at the HTML. And because that's the only real control that we can see, we know it's going to be the first one. So if we go back to the source code for .NET, it's going to be in System Web. Actually, I have it bookmarked. So HTML form is the control, but it's actually not the vulnerable one. HTML form is a subclass of HTML container control, which has a couple other subclasses as well, and I don't remember all of them. But this is where the vulnerability is. Just by hitting spacebar, Reflector decompiles everything. The method that we're looking for is, oh shoot, what's the name of it? Sorry, hang on a second. Oh, here we go, load view state, okay. Load view states does exactly what it sounds like. As .NET traverses the view state hierarchy and identifies which pieces of that hierarchy belong to which controls, pulls out that piece, and then passes the entire save state to that control. So when the form control on the server is receiving its piece of the view state, this is the method that's called, just load view state. It's very simple. There's only one attribute that everything under the HTML container control in .NET reads, and that's inner HTML. So it looks, tries to find it's an attribute called inner HTML. If it finds it, it sets its own property called inner HTML to string. Well, this actually is masking a different method, which we can also view with a reflector. And it's not just a simple string set. What it's doing is it looks at the string that's been passed, and it says, okay, what is this? There's several different types of controls that it could be. One of them is it literal content? Literal content is basically in .NET is just raw HTML. Whatever is there is what's going to be printed in the HTML that's sent to the browser. So .NET takes that HTML that we provided in the attack string, throws it into the control collection, well, it's actually an array, the control array, as a new literal control. We won't go into the code for this, but basically when the web page is rendered, and Rohini touched on this when she was talking about the view state lifecycle, when the page is rendered by the server, it will recursively go back through the object that it has created, and you could say sort of reconstitute it into HTML or convert it into HTML. And part of that is looking at all the members of that controls array and spinning it back. So basically it will just take that attack string from the view state and throw it directly into the HTML. Because .NET is so much simpler in some regards for how it handles view states, there's a lot less potential for attack. And in many regards, is kind of a credit to Microsoft, in my opinion, because the more complexity you throw into something like a view state, the more opportunity there is for attack. By keeping it simple, just sort of a core functionality of what's really needed, it makes the attack window a lot smaller. So this is still not good, but cross-site scripting is a lot better than stealing, passwords and credit card numbers and things like that. Let's see. So what can you do with this? I hit the wrong button. Hang on. Cross-site scripting, we talked about. There we go. You can use cross-site scripting to steal session data and things like that. You can steal application data from JSF. Can also use it to further exploit other vulnerabilities in an application. So, for example, if you are able to grab the database username and password from using an attack against a JSF view state, there's a lot more possibilities that become open then. Really, the specifics depend on how the application is written. The more functionality an attacker, or excuse me, the developer puts into the view state, the greater the attack that's possible. And one thing too that I forgot to point out earlier regarding both of the platforms, but especially with .NET, we focused on the cross-site scripting because that is what is available in the core .NET distribution. It's very easy for developers to start throwing other pieces of data into the view state. Microsoft is fairly conservative in what they put in the view state for a lot of reasons. Performance is one of them, but security, I'm sure, was a factor as well. With third-party controls, with developers, creating custom controls, there certainly could be much more advanced attacks against the .NET view state than just cross-site scripting. But cross-site scripting is what was vulnerable for Microsoft. So, recommendations, always secure the view state. The documentation on that in the past was rather sparse, but there's really no question that it needs to be secured. Both Microsoft and both implementations of Sun Java server faces provide strong functionality for securing it. Microsoft has it enabled by default, so kudos to them. They have it set up with just a simple cryptographic signing. It's easy, automatic, virtually impossible to break without the presence of another vulnerability. But the recommendation that we make is to move the view state to the server whenever possible. There's a lot of advantages to that. Performance is one of them, especially on complex applications. I've seen some .NET apps that have view states that are over 100 kilobytes for just one HTML page, which is ridiculous. I mean, that requires more server CPU time. It makes it slower on the client, takes up bandwidth, et cetera, et cetera. It's also easier to secure because you don't have to worry about it. If it's on the server, you don't have to worry about the user tampering with it. Now, granted, encrypting or cryptographic signing, that should protect it, but who knows what is going to be discovered 2 or 3 years from now. If it's on the server, there's just a lot less to worry about. It is a little bit more complicated in a server farm environment just because whatever signing or encryption key you're using has to be synchronized among the servers, but that's just a configuration option. And really, any decent production environment should have figured out configuration management long ago. That's not really a valid excuse for poor security. The documentation changes are needed by the vendors. I think some of that's been done. To be honest, I haven't had a chance to go back and dig that up. Have you seen changes on JSF? Or? No. Yeah, I think that there were some changes made. But one of the things, too, that I think this shows is that the security industry doesn't make up best practices for fun. It's been a best practice to secure your view state for a long time, basically since any of these technologies came out. And at the time, the security professionals couldn't point to a specific flaw saying, yes, this is going to happen if you don't secure a view state, but professionals are professionals. We know that this types of attacks like this are possible, and so by following best practices before the exploits come out, you save yourself a lot of headache. And one more thing too that I wanted to mention, and I had touched on this earlier in a presentation this morning that I gave with Charles Henderson, about that developers really need to understand the frameworks that they're using. .NET is pretty well documented for the most part. I mean, this was a little ambiguous with this, but at least there was a good default setting. Java server faces was not well documented, and there was a lot of which is how we found this to begin with, because developers just didn't know what they were supposed to be doing. you should not be deploying code that you don't understand into production. It's a bad idea, even if it's not your code. Just because it has Apache or Sun or Microsoft on the name doesn't mean that it's going to be safe.